Okay, so here's a lesson for section 5.5, factoring quadratics in standard form. So factoring quadratics in the form ax squared plus bx plus c. In this lesson, our a value is always not going to be 1, and it can't be factored out. In the previous lesson that we did for section 5.4, we factored quadratics in standard form where the a value was 1, or it could be factored out. So in this lesson, we're going to factor quadratics where the a value is not 1, and it can't be factored out. Okay, so two different ways of factoring quadratics, and we'll have to know them both depending on what type of quadratic we're asked to factor. So I'll just do a quick couple examples reviewing how we factor quadratics when the a value is 1 or it can be factored out. So just a couple quick review examples for that we did in the last section. So here's the steps to factor quadratic in standard form when the a value is 1, okay, when a is 1, or it can be factored out, okay? So these are the steps you do for that. Feel free to pause the video and read them over, but I'll describe them as I go through the examples on the next slide. So here are the examples here. So whenever you're factoring a quadratic, first thing you want to notice, you want to look and see what is my a value for the quadratic. So keep in mind these are in standard form, so ax squared plus bx plus c. So the a value is the number in front of your x squared. So look at your quadratic. What number do you see in front of the x squared? Well, if you don't see anything, you know there's an invisible 1 there. So this is a quadratic where the a value is equal to 1. Okay? So we know how to factor that. All you have to do is find two numbers with a product. So we want to find two numbers with a product of your c value. So a product of 12. So two numbers you multiply to give 12. And also, these two numbers need to add to give you your b value. And there's the b value. So they need to add to give you 7. So we need to figure out what two numbers multiply to give 12, add to give 7. We'll start thinking about what are the factors of 12. You can make a factor tree to find a list of the factors, or you can just make a chart of some sort, and you'll discover that the two numbers that multiply to give 12, that also add to give 7, are 3 and 4. 3 times 4 is 12, and 3 plus 4 is 7. Okay? So those are the two numbers that satisfy that product in sum. So all you have to do now is you have to put those numbers, 3 and 4, into the expression x plus r times x plus s. You have to put them in for the r and the s. Okay? So these two numbers that you found that satisfy the product in sum are your r and your s values. Plug them into this expression, x plus r times x plus s, for r and s. So x plus 3, because 3 is our r value, times x plus 4, because 4 is your s value. So now you've factored this quadratic. If you wanted to check and make sure you factored it correctly, all you have to do is multiply these factors out by using the FOIL method. So multiply each term in the first polynomial by each term in the second polynomial, and you would be right back to your original expression of x squared plus 7x plus 12. So if you wanted, you could double check to make sure you did it right by multiplying that back out. Okay, so the next example, y equals 2x squared minus 2x minus 12. So first thing you want to do when you're asked to factor a quadratic, look at your a value, look at the value in front of the x squared. If it's not 1, the only way we'll be able to factor this, from what we know so far, is if we can factor out this 2. And the only way we can factor out that 2 is if it goes into both of the other terms in the quadratic. So does that 2 divide evenly into negative 2? Yep. Does it divide evenly into negative 12? Yes, it does. So we'll be able to factor out this 2. So I'll show you what that looks like. Remember, in order to factor something out, you put it in front of the brackets, and then divide each of the terms from your original expression by what you factored out, and put that expression inside the brackets. So divide the 2x squared by 2, and I get x squared. Divide the negative 2x by the 2 I took out. Negative 2x divided by 2 will give me negative 1x. And divide the negative 12 by the 2 I took out. Negative 12 divided by 2 is negative 6. And there we go. I now have this expression where I factored out the 2. So I'm going to leave this 2 out here for the rest of the question. It's not really going to affect anything. It's just going to stay there. And now what I want to be able to do, now I have a quadratic inside the brackets where the a value is 1. There's now a 1 in front of this x squared. I know how to factor that. I can factor this the same way I factored the previous question. All I have to do is find two numbers who multiply to give my c value, so multiply to give negative 6, and add to give my b value, and my b value in this question is -1. Okay, so I define two numbers with a product of -6 and a sum of -1, and the two numbers that do that are -3 and 2. -3 times 2 is -6. -3 plus 2 will give me -1. Okay, so these are my r and my s values. And I have to plug those into x plus r times x plus s to get my factors. So let's do that. So I'm going to leave my 2 out front. Don't forget that 2 has to stay there. And now I'm going to plug in my -3 and 2 for r and s into the expression x plus r times x plus s to get my factors for the quadratic x squared minus x minus 6. So I have x plus r, my r value is -7, so I'll have x, or -3, sorry, so I'll have x plus -3, I'll simplify that to x minus 3, times x plus s, and my s value is 2, so x plus 2. And there, I have now factored the quadratic expression y equals 2x squared minus 2x minus 12. If I want to check and make sure I factored it correctly, multiply these three terms out to make sure you get back to your original expression, and you will. Okay. Now what we want to be able to do is we want to be able to factor quadratics where the a value is not 1 and we can't factor it out. So look at this example here, y equals 3x squared plus 8x plus 4. So first thing you want to do is look at your a value. So the a value in this case is 3. 3 is not 1. So the only way I'll be able to factor this is if I can factor out that 3. Okay? So the only way I can factor out that 3 is if it goes into both of the other terms in the quadratic. And it doesn't go into either of them. 3 doesn't divide evenly into 8 or 4. So I'm kind of stuck. I don't know how to factor this. So we need a new method for factoring this type of quadratic where the a value is not 1 and it can't be factored out. So these are the steps for how you'll be able to do these types of problems. If you want, pause the video and read through them now. Okay, now that you've read through them, I'm going to do an example and I'll reference these steps as I go through the example. Okay, so what we want to do, okay, so hopefully you've read those steps, you've read these steps, and I'm going to reference them now. So what you want to do, once again, you're going to look at the quadratic and look at the a value. The a value is not 1, and it can't be factored out because 3 doesn't go into 8 and 4. So what we have to do is we have to find two numbers who have a product of our a times c value. So two numbers who have a product of a times c. So my a times my c is 3 times 4, which is 12. Okay, so I need to find two numbers who have a product of a times c and a sum of my b value. So that part doesn't change. And a sum of my b value, 8. Okay, sum of b, which is equal to 8. So that's what I need to do. So the difference for this type of question, when the a value is not 1 and it can't be factored out, don't forget you're going to have to multiply your a and your c values together. So you're going to have to multiply your a and your c values together, so multiply those. And that's going to give you the number that you have to find a product of. And then you also have to find two numbers who have a product of that, and so a product of your a times c and a sum of your b. So that's what you want to do for these type of questions. So I've made just a little chart here to help you organize figuring out which factors have a product of your a times c, okay, which is 12, so 3 times 4 is 12, and a sum of 8. Okay, so I've made a little chart to help you organize this. You don't have to use this chart every time. You could use a factor tree if you want, or you can just go by trial and error and try and find the numbers on your own. Okay, so in this chart, I'm going to go through it by looking at the factors of the number I need to find a product of. I need to find two numbers who have a product of 12. So I'm going to look at the factors of 12 and then figure out which pair of them will multiply to give 12 and also add to give 8. So what two numbers multiply to give 12? Well, 1 and 12. 1 times 12 has a product of 12, but 1 plus 12 is 13. So that doesn't fit the criteria of having a sum of 8. What other numbers multiply to give 12? 3 and 4 multiply to give 12, but 3 plus 4 is 7, so that doesn't meet the criteria as well. 2 and 6. 2 times 6 is 12, and 2 plus 6 is 8. And that's exactly what I want for this example. I want two numbers who have a product of 12 and a sum of 8. So what we want to do, so now that you've found those numbers, you've found the numbers who, let me just erase that, you found two numbers who have a product of your a times your c value. So my a times my c value is 3 times 4, which is equal to 12. Okay, and a sum of your b value, which in this case my b value was 8. So I found those two numbers. It's 2 and 6. So since the integers 2 and 6 satisfy that product and sum, we're going to break up the middle term. We're going to break up 8x into 2x plus 6x. Okay, so in our original expression, we're actually going to break up the middle term into 2x plus 6x. And we're allowed to do that because 2x plus 6x equals 8x, so that's equivalent. Those two things are equivalent, that's why we're allowed to do that. So after we break up the middle term into those two, what we're now going to be able to do is factor this quadratic by grouping. So hopefully you remember from previous sections in this chapter how to factor by grouping. So let's do that. So my original expression was 3x squared plus 8x plus 4. I found two numbers who have a product of a times c. So I found two numbers who have a product of 12 and a sum of my b value, which is 8. The two numbers that do that were 2 and 6. Okay, so now what I want to do, whenever you're factoring a quadratic where the a value is not 1, after you've found the numbers that have a product of a times c and a sum of b, you break up your middle term into those two factors, 2 and 6. So 8x, I'm going to break that up into 2x plus 6x. I'm going to leave the rest of my quadratic the same, so that plus 4 still stays there and the 3x squared is still at the front. So hopefully you can see how these two expressions are equivalent to each other. Okay, 3x squared plus 8x plus 4 is equivalent to 3x squared plus 2x plus 6x plus 4 because 2x plus 6x equals 8x. So these two expressions are equivalent. Now what I want to do, now that I have the 4 terms, I want to factor this quadratic by grouping. So what I'm going to do, you can follow these steps every time. Just put the first two terms in a group, 3x squared plus 2x, and then put an addition sign, and then put the last two terms in a group, 6x plus 4. And why am I allowed to do this? Well, look, I have a factor, so I have a polynomial plus, so I have a polynomial plus another polynomial. And when adding polynomials, remember, you could just drop the brackets, and that would get you right back to this expression up here. That's why these two things are equivalent. So what you want to do after you've broken up your terms into, broken up your quadratic into 4 terms, you then want to put the first two terms in a group, put the last two terms in a group, and separate them by an addition sign. Always separate them by an addition sign. That's an important step. Now what you want to do is look at each group individually and see if there's anything you can factor out from each group. So in this first group right here, I have 3x squared plus 2x. Is there anything I can factor out between those two? Yes, both of those terms inside the brackets here have an x. So I can factor out the x, and then divide each of the terms in the bracket by what I took out. So divide them both by x. 3x squared divided by x is 3x. 2x divided by x is 2. So I'm left with x times 3x plus 2. And then in the next group, I have a 6x plus 4. Is there anything that goes evenly into 6 and 4? Yep, they're both even numbers, so I know 2 goes into both of them. 2 goes into 6x, so divide 6x by what I took out. 6x divided by 2 is 3x. Divide 4 by the 2 I took out, and I get 2. There we go. So now, I've factored each group, and what you will always be left with at this point in the question, as long as you have chosen the proper numbers that have the product and sum of a times c, so a product of a times c and a sum of b, as long as you've chosen those proper numbers and done all the steps properly, you will always now have a common binomial factor. Okay, so we've got two terms. We've got this term and we've got this term, and what do they both have in common? They both have a 3x plus 2. Okay, so this is a 3x plus 2, this term has a 3x plus 2. Since both of those have that in common, we can factor out that binomial because both terms have that binomial in common. So what I'm going to do, I'm going to factor out the 3x plus 2. So once I've factored out the 3x plus 2, so I've factored it out from this term, I've factored it out from this term, what I'm left with after I've divided both terms by that 3x plus 2, they'll both be gone, and what I'm left with is x plus 2. Okay, I'm left with my x plus 2 as my second factor, the x plus 2. Okay, so if you can't remember how to do that binomial common factoring, go back to previous lessons for this chapter to figure that out. Okay, so and that's my final answer. I've now completely factored that quadratic. All I'm left with is 3x plus 2 times x plus 2. Those are my two factors for this quadratic. I am done. Okay, let's do another example. Let's not use this chart this time. So let's factor the expression, the quadratic expression, 6x squared plus 11x plus 4. So hopefully you remember you want to look at your a value first. So let's look at our a value. It's a 6. So 6 isn't equal to 1, okay? So now I want to see, can I factor out that 6? Does that 6 go into the other two terms? Does 6 go into 11 and 4? No, it doesn't. So this is a quadratic where the a value is not 1 and it can't be factored out. So I'm going to have to factor this by grouping. I'm going to have to break up the middle term into two terms and then factor this by grouping. Okay? So you always have to factor by grouping when the a value is not 1. So how do I do that method? Hopefully you remember the first step is you want to find two numbers who have a product of your a times your c value. So product of a times c, so that means a product of 6 times 4, and 6 times 4 is 24. So I need two numbers who have a product of 24 and a sum of your b value. The sum of your b value, which in this case is 11. Okay, so product of 24 and a sum of 11. So if you want now, what you can do is you can use the chart, you can make a factor tree, like you can make your factor tree by putting 24 and then listing the numbers that are factors of 24, like 4 and 6, and break this up, and so on. And that way you would figure out which numbers multiply to give 24 and add to give 11 using the factors from the factor tree. Or what you can do, which hopefully you'll get good at, is just being able to look at the numbers and being able to determine them just by a little trial and error process. So I need to find two numbers with a product of 24. So what two numbers multiply to give 24, but yet also add to give 11. So what two numbers do this? Well, these two numbers are 3 and 8, because 3 times 8 is 24, yet 3 plus 8 is also 11. So since integers 3 and 8 satisfy this product and sum, break up 11x into 3x plus 8x, and then factor the quadratic by grouping. And you have to factor a quadratic by grouping if the a value is not 1 and can't be factored out. So I just want to reiterate the important part of doing these types of questions when the a value is not 1 and can't be factored out is you define two numbers with a product of your a times your c value. Product of that, and then a sum of your b value. Then break up your middle term into the numbers that satisfy the product of sum, and then factor by grouping. So the original quadratic I started out with was 6x squared plus 11x plus 4. I found two numbers with a product of a times c, so a product of 6 times 4, which is 24, and a sum of my b value, which is 11. And I found out those two numbers are 3 and 8. So what I'm now going to do is break up the middle term into 3x plus 8x. Leave the rest of my quadratic the same, so leave the 6x squared at the front and the plus 4 at the back. And now I'm going to factor this by grouping. So whenever you want to factor by grouping, you can follow these exact same steps. Just put the first two terms in brackets, 6x squared plus 3x, put those in brackets. Then put an addition sign. Then put the last two terms in brackets, 8x plus 4. So it's important that you separate your two groups by this addition sign. That's what makes this. That's what allows you to just put the brackets up. 8x. Sorry, this should 8x plus 4 there. Okay, because these two expressions are equivalent. Because when you add polynomials, you can just drop the brackets or put up the brackets. It doesn't matter. Okay. Now what we want to do is factor each group. So look at the first group. What goes into 6x squared and 3x? Well, look at the coefficients, 6 and 3. 3 goes into both of those, so I can take out a 3. And both terms have an x, so you take out the x with the smallest exponent. So I have an x squared and an x to the 1. So I take out the x to the 1. Then divide each of the terms inside the brackets by what I took out. 6x squared divided by 3x. 6 divided by 3 is 2. X squared divided by x is x. And now I have a plus, divide the 3x by what I took out. So 3x divided by 3x, anything divided by itself, gives you 1. Now look at the second group. I have 8x plus 4. What goes into 8 and 4? Well, I could take out a 4. Divide each of the terms in the brackets by what you took out. 8x divided by 4 is 2x. 4 divided by 4 is 1. And once again, because I've done this properly and I've chosen all the proper numbers, I end up with this common binomial. So when you have a common binomial, you can factor out that common binomial. So put that out front, 2x plus 1. Now that I've factored that out, all I'm left with is 3x plus 4 for my second factor, 3x plus 4. And there we go. I have my two factors for the quadratic, 6x squared plus 11x plus 4. I'm done. If you wanted to check and make sure you did this right, multiply out these two factors, 2x plus 1 times 3x plus 4. Using the FOIL method, and you'll be right back to your original expression, 6x squared plus 11x plus 4. Okay, let's do another example. Okay, so factor 3x squared plus 7x plus 2. So we've got a quadratic in standard form. Look at your a value. The a value is not 1. So now what you want to do is check and see if you can take out, if you can factor out that 3. If we could factor out this 3, then we'd be able to use the short method for factoring for when the a value is 1, which we did on the previous lesson. But we can't because 3 doesn't go into 7 or 2, so we can't factor out that 3. So we're going to have to factor this one the long way by grouping. Okay? In order to factor it by grouping, we're going to have to break up our middle term into two terms. And how we determine what to break up the middle term into is by finding two numbers who have a product of a times c. We need two numbers with a product of a times c, which is, here's our a value, 3. Here's our c value, 2. So two numbers with a product of 3 times 2, which is 6. So numbers with a product of 6. And a sum of our b value. Our b value is 7. So we define two numbers with a product of a times c, which is 6. And a sum of our b value, which is 7. So what two numbers multiply to give us 6, yet also add to give us 7? So the two numbers that do that are 1 and 6. 1 times 6 is 6. 1 plus 6 is 7. Since the integers 1 and 6 satisfy our product and sum, what we're now going to do is break up the middle term, 7x, into 1x plus 6x, because 1x plus 6x is 7x. But now that we've broken up the middle term into two terms, our quadratic now is 4 terms, and we can factor it by grouping. So let's do that. So I have 3x squared, 3x squared plus 7x plus 2. I found, since our a value is not 1 and it can't be factored out, I needed to find two numbers who had a product of a times c, which was 3 times 2, which equals 6, and two numbers that have a sum of our b value, which was equal to 7. I determined the two numbers that do that are 6 and 1. That's why I'm breaking up my middle term into 6x plus 1x. Okay, 6x plus 1x is 7x. Leave the rest of the quadratic the same. And now factor it by grouping. So what I need to do now, put my first two terms in a group, 3x squared plus 6x. Put the last two terms in a group, 1x plus 2. And then don't forget to separate these two by an addition sign to make sure that this expression stays equivalent to the one above. Okay. So now what I want to do is I want to factor each group separately. So look at the first group. See what goes into 3x squared and 6x. What goes into 3 and 6? 3 goes into both of those. And both terms have an x. You take out the x with the smaller exponent, so I take out an x to the 1. Now divide each of the terms by what you took out. 3x squared divided by 3x. 3 divided by 3 is 1. X squared divided by x is x, so I have 1x. Now divide 6x by the 3x I took out. 6 divided by 3 is 2. X divided by x, those cancel out. X divided by x is 1, so I'll have 2 times 1, which is just 2. Okay, so the x's just cancel out. And in the other one, what goes into 1x plus 2? Nothing other than 1 goes into both of them. Okay, so just to make it easier visually for what we're about to do in the next step, I'm actually going to write a 1. So I'm going to factor out a 1. So if I divide both of the expressions on the inside of the brackets by 1, I'm left with exactly what's there right now. Just a 1x plus 2. Okay? So I couldn't factor anything out other than a 1. So I just put a 1 out front. And then when you divide step by 1, nothing changes. So what I have now you'll notice, once again, you have a common binomial. So both of the terms have a 1x plus 2. So what I can do is I can factor out that common binomial. So factor out the 1x plus 2. I'm just going to write it as x plus 2, because 1 times x is just x. After I've factored these out, what I'm left with, my second factor, is just 3x plus 1. 3x plus 1. And now I'm done. I've got my two factors for the quadratic 3x squared plus 7x plus 2. You could check to make sure this is the right answer by multiplying these terms out using the FOIL method to make sure you get back to your original expression up here. Okay, let's do another example. Let's factor 6x squared minus 5x plus 1. So once again, when you want to factor a quadratic that's in standard form, you want to look at your a value and see, is it 1 or is it not 1? So 6 is not 1, so I'm going to have to factor this one by grouping, unless I can factor out that 6 right away. Does 6 go into 5 and 1? No, it doesn't. So I'm going to have to factor this one the long way by grouping. So what I have to do, I have to find two numbers who have a product of a times c, which is equal to, so a times c, which is 6 times 1, which equals 6. I need to find two numbers with a product of 6 and a sum of my b value. My b value is negative 5. So I need to find two numbers with a product of 6 and a sum of negative 5. So what two numbers multiply to give 6 and add to give negative 5? The two numbers that do that are negative 2 and negative 3. Negative 2 times negative 3 is 6. Negative 2 plus negative 3 is negative 5. So since negative 2 and negative 3 satisfy the product and sum, I'm going to break up my middle term, negative 5x, into negative 2x minus 3x. Because negative 2x minus 3x is negative 5x. That's why I'm allowed to do that. And then I'll have a quadratic with 4 terms. I can factor it by grouping. So I have 6x squared minus 5x minus 1. I found two numbers who have product of a times c, which was 6 times negative, what was it, plus 1 or minus 1? It was plus 1, sorry. So I found two numbers who had a product of a times c, which was 6 times 1, which equals 6. And the two numbers also have to have a sum of my b value, which equals negative 5. I found out the two numbers that do that are negative 2 and negative 3. So what I want to do is break up my middle term into negative 2x minus 3x. I'm allowed to do that because negative 2x minus 3x is negative 5x. Leave the rest of the quadratic the same. And then what I'm going to do is put these, so now that I have 4 terms, I can factor it by grouping. Put the first 2 terms in a group. Put the last 2 terms in a group, so the negative 3x plus 1. And then don't forget, separate those two groups by an addition sign. That's very, 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 very important to do that. Okay, that's what keeps the expression equivalent to the one above it. Okay, so even when you have this minus here, make sure that stays with the negative 3x. It stayed with the negative 3x there. And then separate the groups with an addition sign. Whenever you're factoring by grouping, you're always going to separate with an addition sign. Always, always, always. Now what you want to do is factor each group. So I have 6x squared minus 2x. What goes into both of those? Well, I could take out a 2x from this one. So divide each of those terms by 2x. 6x squared divided by 2x will give me 3x. And then negative 2x divided by 2x will give me negative 1. Now the next group. So I have negative 3x plus 1. Whenever you have a negative in your first term, like this, you always want to, at the very least, factor out a negative 1. So that's no longer a negative in the first term in the brackets. So does anything else go into 3x and 1? No, nothing else goes in. So what I'm going to do, I'm going to factor out a negative 1, so that negative in the first term will be gone. So I'm going to factor out a negative 1. And what I'm going to be left with, if I divide each of those terms by negative 1, it's just going to change the sign of each of them. Negative 3x divided by negative 1 is going to give me positive 3x. 1 divided by negative 1 is going to give me negative 1. And then I've got a plus and a minus beside each other. What I'm going to do is I'm going to simplify that. I know a plus and a minus beside each other simplifies to a minus. And now what I'm left with, once again, I have a common binomial. I've got a 3x minus 1 in both of the terms. So what I can do is I can common factor out that common binomial, put that out front, so put the 3x minus 1 out front. After I common factor that out, divide both sides by that 3x minus 1 that I took out. They'll both be gone, and what I'm going to be left with is 2x minus 1 for my second factor. And there we go, I'm done. And once again, you can check your answer by multiplying that out and making sure you get back to your original question. Okay, next one. So I just put this one in here as a reminder that whenever you're doing, whenever you're factoring a quadratic, you should always common factor out any number that you can before you start the question to make it as easy as possible for you. Okay, so first thing you're going to do, you're going to look at your a value. The a value is clearly not 1, it's 16. So you want to see, can I common factor out a 16 from all of the terms in this quadratic so that I'll be able to factor this the short way. Does 16 go into 26 and 12? No, it doesn't go into either of those. So I'm not going to be able to common factor out the 16. I'm going to have to factor this one. I'm going to have to factor it by grouping. Okay, I'm going to have to break up that middle term into two terms. But before I do that, remember that just because you can't common factor out a 16 doesn't mean that there's nothing else you can't common factor out to make it a little bit easier to work with. So notice that all three of these terms are even numbers, 16, 26, and negative 12. So what I could do, I know I can at the very least common factor out a 2. Common factor out a 2, divide each of the terms by 2. 16 divided by 2 is 8, so I have 8x squared. 26 divided by 2, I'll get, 13. So plus 13x, and negative 12 divided by 2, negative 6. So now I've factored out a 2, I'm left with a quadratic inside the brackets that has smaller numbers, they'll be easier to work with. So what I have here, find two integers, so if I want to factor this quadratic inside the brackets, once again I'm going to need to find two numbers who have a product of my a times my c, so product of a times c. Okay, I have to do that because remember this a value is not 1, it's an 8. So I need to then multiply that by the c value and find two numbers with a product of that. So 8 times negative 6 is negative 48. And I also need to find the two numbers that multiply, so they multiply to give negative 48, and who have a sum of my b value, which is 13. Okay, so I need to find two numbers who have product of negative 48, sum of 13. So what two numbers multiply to give negative 48 and add to give my b value of 13? And the two numbers that do that are 16 and negative 3. Okay, 16 times negative 3 is negative 48. 16 plus negative 3 gives me 13. So since those integers, 16 and negative 3, satisfy the product and sum, I want to break up my middle term. My middle term was 13x, so I want to break up that 13x into 16x minus 3x. And I'm allowed to do that because 16x minus 3x equals 13x. So now what I'm going to do is I'm going to break up, I'm going to rewrite my quadratic that I had here. I'm going to break up the middle term for the quadratic inside the brackets and then factor it by grouping. So I had my quadratic, it was 2 8x squared plus 13x minus 6. Okay, so don't forget, you have to leave this 2 out front. That's very important. You can't just get rid of it right now. And then what I did, I wanted to factor this quadratic inside the brackets. It's a quadratic where the a value is not 1, so I knew I had to factor it by grouping because I couldn't factor out that 8. So what I had to do, I had to find two numbers who had a product of the a times c value, which was 8 times negative 6, which is negative 48, and two numbers who also not only had a product of that, but a sum of my b value, which was 13. I discovered that the numbers that do that are 16 and negative 3. So what I want to do is I want to break up this middle term in this quadratic into 16x minus 3x. And leave the rest of the quadratic the same. And don't forget to leave that 2 out front. Okay, it can't just disappear. Now what I need to do is I need to break up this quadratic into two groups, the same way I did before. I'm going to break it up into two groups. I'm going to have a bigger set of brackets here just so you remember that there's a 2 being multiplied by this whole thing out front. It's not going to affect anything, but it still has to be there. So put the first two terms in the first group, then put the last two terms in the next group. Don't forget the negative stays inside the brackets here. It stays with that 3x, so I have negative 3x minus 6. And then don't forget, you always separate these two groups with an addition sign. You have to remember that addition sign. That's what keeps it equivalent to that expression up there. Now what you want to do is factor each of the two groups. So what goes into 8x squared and 16x? Well, 8 goes into 8 and 16, so I can take out an 8, and they both have an x. Take out the one with the lower exponent, so I take out an x to the 1. Divide each of the terms by what you took out. 8x squared divided by 8x is just x. 16x divided by 8x is just 2. And then the next one, the next group, I have negative 3x minus 6. Remember, whenever the first term in the group has a negative, you need to take out a negative. So what I need to do, what goes into negative 3 and negative 6, I can take out a negative 3. So I'm going to take out a negative 3, divide each of the terms in the brackets by the negative 3 I took out. Negative 3x divided by negative 3 gives me x. Negative 6 divided by negative 3 gives me positive 2. Then I'm going to simplify. I have a positive and a negative beside each other right here. I'm going to simplify that to a minus. So what I'm left with now is I have inside this, inside the big brackets here, each of my terms have an x plus 2. They have a common binomial, so I can factor out that common binomial, and then I will be done with my factoring my quadratic. So that 2 stays out front. Then what I'm going to have is I'm going to factor out the x plus 2. After I've factored out this x plus 2, what I'm going to be left with is 8x minus 3 for my next factor. 8x minus 3, and I'm done. I now have my factors of my original quadratic. 2 times x plus 2 times 8x minus 3. And if you multiplied that out, you would be done. You would see that you would get back to the original expression. Okay, so that's it for that one. If you forgot to factor out the 2 at the very beginning, once you went through and you factored your quadratic, you would have done it with bigger numbers. It still would have worked, but what would have happened is in one of your factors at the end, you would have been left with another common factor that you could have taken out from that. So if you then take out that common factor, like for example, you might have had 2x plus 4 times 8x minus 3, but that wouldn't be complete because this 2x plus 4, you can take out a 2 from that, and you'd be left with 2 times x plus 2 times 8x minus 3, and then you would be done. So you would essentially you would factor out that 2 just at a much later point in the question. Okay, but if you take it out at the beginning, you'll be working with much smaller numbers, and it'll be much easier. Okay, now let's do one where we've got we're factoring a trinomial when there's two variables. Okay, so what we want to do in this situation, you're just going to follow the exact same steps, and it's going to work out the exact same way. So if your a value is not 1, okay, what you want to do is you're going to need to factor this by grouping, unless you could factor out that a value. Does 10 go into 3 and 4? It doesn't, so we're going to have to factor it by grouping. In order to factor it by grouping, we're going to have to break up into the middle term into two terms that have a product of a times c, so a product of negative 40, and a sum of your b value, a sum of negative 3. Okay, and the two numbers that do that, who multiply to give negative 40, add to give negative 3, are negative 8 and 5. So since negative 8 times 5 equals negative 40, negative 8 plus 5 equals negative 3, we're going to break up our middle term, negative 3xy. We're going to break that up into negative 8xy plus 5xy. Negative 8xy plus 5xy equals negative 3xy. That's why we're allowed to do that. So let's do that. So my original expression was 10x squared minus 3xy minus 4y squared. I'm going to break up my middle term into negative 8xy plus 5xy leave the rest of the quadratic the same. And now what I want to do is put the first two terms in a group. 10x squared minus 8xy. Put the last two terms in a group, 5xy minus 4y squared. And then don't forget to separate those two groups with an addition sign. Then factor each group separately. What goes into 10x squared and 8xy? Well, what goes into 10 and 8, I can take a 2 out. And both of the terms have an x, take out the one with the smaller exponent, so I can take out an x to the 1. Then divide each of these terms by what I took out. I get 5x minus 4y. And then in the second term, nothing other than 1 goes into 5 and 4, but they both have a y, so I can take out the y with the smaller exponent, so a y to the 1, divide each of the terms by y, and I get, once again, 5x minus 4y inside the brackets. So I have a common binomial. That's good, that's what's supposed to happen when I'm factoring by grouping. So what I can do is I can factor out that common binomial, so put that out front, 5x minus 4y. After I've factored that out, what I'm left with is 2x plus y as my second factor. 2x plus y. And then I'm done. Okay, let's just do one more quick example for factoring a quadratic. For this one, first thing you want to do, once again, is you want to look at your a value. I'm just going to get rid of these steps on the side here. So I want to actually take a minute right now and try to factor this one yourself, and you should get the answer that's at the bottom here. 5 times 2x minus 1 times x plus 2. So try it out yourself, see if you can get that answer. So pause and try. Okay, now that you've tried it, I'm going to take you through how you would do this one. I'm going to do this one a bit quicker than the other ones probably, and go through the steps quickly. And then hopefully I'll show you how we can get to that answer. So what I have here, I have a quadratic that wants to be factored. In order to do that, I need to look at the a value and see, is it 1 or is it not 1? Can it be factored out or can't it be? That's going to determine which method I'm going to use to factor this. So I have my a value is 10. So I'm going to have to factor this by grouping unless I can factor out that 10. Does 10 go into 15 and 10? Goes into 10, but it doesn't go into 15, so I can't factor out that 10. So what I'm going to have to do, I'm going to have to factor this one by grouping. But remember, before you start factoring it by grouping, check and make sure, is there any, even though the 10 doesn't go into all of the terms, is there a common factor that goes into all of them that will help me work with smaller numbers? In this case, yes, there is. 5 goes into 10, 15, and 10. So what I'm going to do is I'm going to factor out a 5 to start with. So divide each of those terms by 5, and I'll have 2x squared plus 3x minus 2. So now I have a quadratic inside the brackets here that has much smaller numbers than my original quadratic. So I'm going to be able to still factor this by grouping, but it'll be easier because it's smaller numbers. Just don't forget that that 5 has to stay out front this whole time. It's not going to affect anything, but it has to stay out front. So now what I want to do, inside the brackets here, I have a quadratic where the a value is not 1, it's a 2, and I can't factor it out. So what I need to do is I need to factor it by grouping by fine-tuning to a product of my a times c. That's the important part. That's what's different about these types of questions. Product of a times c. Okay, so 2 times negative 2, which is negative 4, and a sum of my b value, which is 3. So what two numbers multiply to give negative 4, but have a sum of 3? So the two numbers that do that are 4 and negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is 3. So what I need to do is I need to break up my middle term here into 4x minus 1x. Because 4x minus 1x is 3x, that's why I'm allowed to do that. Okay? And don't forget to leave the rest of your quadratic the same. Now what I want to do, since I have a quadratic in the brackets here with 4 terms, I can now factor that by grouping. So what I want to do is put the first two terms in a group, 2x squared plus 4x, put those in a group. Put the last two terms in a group, make sure I keep the negative with the 1x, so negative 1x minus 2. And then make sure you separate these two groups always with an addition sign. Now what you want to do, factor each of the groups separately. What goes into 2x squared and 4x? Well, I can take out a 2x. divide both of those terms inside the brackets by 2x, and I'm left with x plus 2. The next group, the first term has a negative, so I know I definitely need to factor out a -1 at the very least. And in fact, that's the only thing I can factor out from those two. So divide them both by -1, and I'm left with, once again, x plus 2. So now you should see you have that common binomial once again. So you can common factor out that common binomial. And don't forget that 5 still has to stay out front, but common factor with that common binomial of x plus 2. After you do that, what you're left with is 2x minus 1 as your second factor. And that's how we got to this answer of 5 times 2x minus 1 times x plus 2. And you might notice the order of the factors doesn't matter, okay? The fact that it says x plus 2 times 2x minus 1 instead of 2x minus 1 times x plus 2 doesn't matter. Because if you think about it, it's like saying, does it matter if you write 5 times 2 or 2 minus 5? No, it's the exact same thing, okay? And I think we'll leave it at that for now, okay? So make sure you go to jensenmath.ca and download the worksheet and try it out. If you have any questions, make sure you let me know.